In this video, we're going to talk about what a system of equations is and what the solution to a system of equations represents. So by definition, a system of equations is two or more equations with the same variables. So down below, you'll see three different examples of systems, and they're written in all different ways with all different variables with a different number of equations, but they are all systems. So notice that in this first one, we have two equations with two different variables. That meets the requirements of a system. It's two or more equations with the same variables. Here in the second set, again, we have two or more equations with the same variables. They both contain A and B. And then here in this third example, we have three equations, which again fits that definition of two or more equations, and they again have the same variables of M and W. So the variables don't matter as long as they have the same variables, and as long as they have two or more equations of any type, it is considered a system. So on this slide here, what I've done is I've taken two equations with the same variables, which means it is a system of equations, and I've graphed them on the same coordinate plane. So here is the graph of x plus 2y. Here is the graph of 3x minus 2y equals 5. Now if we look at this graph, what we'll notice is that there's a very important key point on this graph. While there's a lot of points on the graph, there is one point in particular right here where the two equations cross. And when we're solving a system of equations, this is ultimately what we are going to find. The solution to a system of equations represents the point, you'll notice that it's a point, where the two equations intersect or cross. And if it were three equations, it would be 3 or 4 or 5, depending on how many equations that system has. But when we're solving a system of equations, what we are ultimately finding is this point of intersection. And what this point of intersection represents is it represents the single point that will work in both equations. So we can even check this given the image that we have. So we notice here that we have the point x is 3, y is 2. And so what I can check is I can check and make sure that this point works in both of these equations. So x is 3, so we have 3 plus 2 times the y coordinate here is 2 is equal to 7. Well, that's 3 plus 4 equals 7. So 7 equals 7. So yes, this point works in equation 1. Then here in equation 2, we'll do the same thing. So we have 3 times 3 minus 2 times 2 equals 5. So we end up with 9 minus 4 equals 5, and then 5 equals 5. So what we can see here is that this point works in both equations in our system, and that's because it's the one point where they cross. So as we solve our systems of equations, we can always check our answers by taking the point that we find as our answer and substituting it back into both of our original equations and making sure that it makes both of our original equations true.